Data Futures Base West is a precinct to prepare us for the future now. It builds upon the rich heritage of Base West to establish a high-tech research precinct in which the data center plays a pivotal role as an urban catalyst to ensure this phase of transformation equips us to face our challenges now and into the future. The design of the data center focused on 5 key principles to guide its development. Firstly, the data center must integrate and empower research across the master plan to achieve the identified sustainable development goals. Secondly, Data Futures will revitalize the heritage of Base West through sustainable adaptive reuse of the grain silos and embed designing with country frameworks. To achieve this, a modular building strategy has been developed with a key focus on circular building principles, as well as a design for manufacture, assembly, and disassembly. As a research precinct, the data center will be at the forefront of technology, utilizing immersive cooling and co-robotic maintenance to maximize efficiency and minimize downtime. Finally, the heat waste produced from the data center will be reused throughout the agri-tech precinct for the research and development of future food practices. Data Futures Base West responds to the urgency of action outlined through the United Nations Sustainable Development Goals identified during our master planning phase. Throughout the history of Glebe Island, the grain silos have undergone significant change from its original configuration to what is currently found on the site. The original silos footprint provide an opportunity to embed place storage within the site with a designing with country framework. A key focus of this area is to create regenerative public spaces that utilize cultural stories and native ecologies that perform as civic, public, and ceremonial spaces. It is often said that the greenest building is the one already built. Research has increasingly supported this statement, finding that adaptive reuse of existing buildings can result in fewer adverse environmental impacts than sustainable new construction. We have seen the adaptive reuse of the Glebe Island silos throughout its history, from first being a vessel for grain storage to cement and sugar in the 1990s. Throughout the next phase of the silos transformation as a data center, a modular building strategy will be incorporated as a key framework which enables an efficient and flexible data center layout. This also provides a framework for a diverse range of future uses after its life as a data center. The building utilizes a modular design strategy which incorporates circular construction principles and is designed for manufacture, assembly, and disassembly. These modules can be prefabricated off-site and lowered into the silos during construction. The family of modules consists of the primary data center, office, vertical farming and germination modules, as well as service modules consisting of vertical transport, electrical distribution, network distribution, backup generators, and cooling. The building planning strategy is divided into 4 primary data center bays, with 3 intermediate amenity and vertical transportation zones. The lowest floor plate band begins with the immersive cooling supply system. Next are the data center levels, and then the heat reuse and agri-tech modules. The servicing silos are comprised with electrical distribution A and B, as well as backup generators. Vertical transportation is spread evenly across the building. The data center utilizes an immersive cooling strategy to reduce the overall footprint of equipment required when compared to a traditional data center arrangement. A traditional server arrangement would require 6,000 5-kilowatt racks to achieve a 30-megawatt data center. With the high-density arrangement possible with immersive cooling, this would be reduced to 300 immersive cooling modules. The cooling strategy utilizes a non-conductive liquid for the immersive cooling of data center equipment. This is pumped through the building, bringing the heated liquid to germination module. Here, the heat is reused to maintain a constant temperature of around 30 degrees to promote the success of seed germination. The heat is then rejected through the use of a cooling fan, which can also control the temperature of the farming module above. The cooled liquid is then returned to the initial tank for the process to repeat. The power strategy utilizes the service module to connect to the data center module through a high-level service reticulation zone. Co-robotics is implemented within the vertical farm and data center to improve efficiency and reduce overall downtime. The Agritech precinct is expanded as a showcase for public engagement through the adaptive reuse of the gypsum storage facility. Today, we have explored how these 5 key principles have shaped Data Futures Bays West. To know the future, we must first know the past.